Hi, welcome back to Shitoku Tech. Previously, we got to unbox the GeniaTech XPI-3566-Zero, and we got started with it, configuring the OTG port so we could use a keyboard and a mouse with it. So that's when I get the idea that I want to do some burn-in testing, kind of little stress test. And that reminds me, I have this whole series of versus videos where I tried different SBCs, even though these SBCs are much bigger than the XPI 35660. I want to do a versus comparison of all of my boards. We got the sweet potato, lay potato, Raspberry Pi 4, Raspberry Pi 5, and we're going to see how the numbers stack up across the board, even though this board's just a fraction of the size. Yeah, and we also want to measure the temps while we're doing the stress testing. You got the CPU, the memory, and the eMMC. I imagine those all heat up. We're going to use the same methodology as we did for the other Versus episodes. Yeah, we're going to use Sysbench, testing the CPU, testing file I/O, testing the memory. So first, let's check and see that we've installed Sysbench. I'm just going to run sudo apt install Sysbench. Then you hit enter. And you confirm that I just did it 5 minutes ago. Okay, great. All right, so we're going to run the CPU test. That's basically calculating prime numbers up to 20,000 of them. Copy that. And then we paste it. Hit enter. And it's running in the background there. And there's the results. Yeah, I don't want to dig into the numbers. This is what the results look like. We'll get all the numbers together with the other boards, and then we'll go into details there. Now this is writing 2 GB files in the I/O system, up to 128 of them, and then deleting them all. So we'll go ahead and run that. I'm not going to crop this one out. Yeah, it's just going to create 128 files, 2 GB files, and then delete them. Almost there. Okay. I don't want to get too far into the numbers here again. I want to wait for the comparison when we have all the numbers together. So let's run the next test. This is reading and writing 2 GB of data in the memory. How many times can it do that? How fast can it do that? I think it's a fixed number of events and you're up against the time basically. Yeah, there we go. It's a fixed number of events and it's how long it takes you to do it. And minimum, average, and 95th percentile are all zeros across the board. Okay, let's get some of our temps here. There's the CPU. That's coming in at $1.13 there. That's Fahrenheit. I'd be concerned if it was Celsius. And there's the memory chip coming in at $1.18. Yeah. Yeah, here's the eMMC, and that's similar at $1.18 there. Oh no, $1.13 on the eMMC. All right. Okay, so we have a feel for how well this board performs and what kind of temperatures it can tolerate. Got our stress test done. Oh, there we see it's already cooled down to like into the 90s. Yeah, 92, 93. That's the memory chip there, and we see that's coming down. You can see it's cooling off, $1.12, and the numbers are going down. Yeah, 90 degrees on that CPU. So it cools down pretty quickly after that stress test. All right, so here's the numbers. And you can see XPI-35660 easily is better than sweet potato or lay potato in this particular series of tests, coming in a solid third place. Total time's the same for all of them. Yeah, lay potato had some fluky incident here with latency max on the CPU during the testing. Yeah, lay potato there coming in last place. Sorry. XPI-00 again. XPI-3566-Zero again coming in a solid third place. Total time 1 minute for the memory test. And it's really close to the Raspberry Pi 4. Almost took a minute. Raspberry Pi 5 took less than half a minute, so it's kind of hard to beat that. But you can see XPI-35660 very close to the Raspberry Pi 4 in the memory performance. So for the I/O test, yeah, this wasn't impressive, but we still beat the sweet potato and lay potato. Nowhere close to Raspberry Pi 4, which was actually better than Raspberry Pi 5 somehow. When I did those testings, it was on the same SD card, so we were comparing oranges and oranges. We're going to do another I/O test. We'll do that in a second. But you see, the XPI-35660 fared pretty well against these boards. Here is pibenchmarks.com. You copy and paste this URL. It runs a battery of tests against your eMMC or your SD card, and then actually uploads the results to the website so that you can compare it to other devices. So here I am pasting that command. We're going to crop some of this out because it runs over 2 minutes, and it's hard for me to describe what's going by on the screen, etc. So we'll crop and compress. Give it a few seconds here. Okay, when you get to the end, you can type in your description of the device. So I'm going to go ahead and type in XPI-35660. And you can also include a username. I liked it because I was able to search for all of my devices under Shotoku Tech. There we go. And here, searching for Shotoku Tech on pibenchmarks.com, you can see the XPI-35660 eMMCs double the score of the eMMC for lay potato. And of course, yeah, there's no competition with the SD card at all. Score of 551. But yeah, double the score for the XPI-35660. Congratulations. All right. So look for the product page down below. Give this video a like. Leave a comment. And before you go watch more of my XPI-35660 videos, please click on subscribe. Thank you very much.